Is the screen visible? Yes. Is the screen visible? Okay. Okay. Now see here. You write down the example. This is for 10 marks in descriptive questions. Write down example. Using bilinear transformation, design a Butterworth filter which satisfies the conditions 0.8 less than or equal to h e to the power j omega less than or equal to 1 in the range 0 to 0.2 pi. Omega, this small w lies between 0 to 0.2 pi, right? And h omega, magnitude h omega is less than or equal to 0.2 in the range 0.6 to pi. Have you noted example? Now this is for 10 marks. You refer any question paper. In 100% question papers, there is a one question on Butterworth filter design using either bilinear or impulse invariant. Without, you can refer all 10 years papers. You will find that there is a one question. So 100% this is are there. Yes. Which are these specifications? Specifications are given. Yes, specifications are, tell me, are of which filter, digital filter or analog filter, which are given to you. In the example, you are given specifications of analog filter or digital filter which is to be designed. Answer B. Yes. Yes. Pranav. We can convert digital to analog. Okay. What I asked, specifications are of which filter? Devashri, I asked you the specifications are of which filter? These are of analog filter or digital filter. I know that we have to design the filter and first step is convert digital to analog. Okay. The question is, whatever the specifications are given, frequency response, magnitude of the frequency response from this, it lies between 0.1 to 1. It is of analog filter? No, it is of digital filter. Why it is of digital filter? See, W, small w is used here. In analog filter specification, we are using omega. Can you listen? Devashri, can you listen? Yes. Have you understood? See, we are always using omega for analog one, for analog frequency. And here what is used? Here what is given? W is given. So you are given, yes, specifications of, yes, which filter? Digital filter. Okay. Now see here, this should not be the actually, this is last but one example, last but one lecture on filter designing. Chebyshev filter is left to you. You have to study because in depth we are studying this Butterworth filters. Chebyshev filter only formulas are different. So now see here, it is clearly small w is given. So now, so if we are using this w, this is a w, right? What does it mean? This is a digital frequency. And here also h of j omega, otherwise you have to write magnitude response for filter transfer function. Here it is h of e to the power small g, j omega is written jw, right? And again, one more difference you will find that it is given up to pi only, right? So what is the minus pi to pi is the frequency range for digital filter. So now you are given the specifications of digital filter, right? And you have to design, yes, using Butterworth approximation so that we should get this type of frequency response. Butterworth approximation and bilinear transformation. This is given in example. So you should know what is given. Then only you can proceed for solution. Now, from the given data, you can draw the frequency response, which is required on this axis e to the h e to the power j omega, or it is same as that of h omega, right? This is same as that of h of omega, magnitude response. In the frequency response, you have magnitude response, you have phase response. So here you are taking magnitude. So it is magnitude response. So magnitude response, this is the graph of magnitude h of e to the power j omega or h omega versus w, right? So w is a digital frequency. Here is 0 to pi. On this axis, if you write down up to minus pi, it is symmetric like this, right? It is a periodic one. So now see what is given. The magnitude remains in between 1 to 0.8, right? It is less than 1, greater than 0.8, less than 1, greater than 0.8, right? In the range, yes, in the range, yes, 0 to 0.2 pi. In the range 0 to 0.2 pi. This is how we have to first draw the diagram like this. Are you getting, all of you? Yes? Are you getting? Only Devashri is answering. What about other students? What about other students? All will have to appear for exams. All will have to solve the papers. It may be descriptive, it may be MCQ. And you find that, yes, you will find that in MCQ, just now you can take the experience of this batch, earlier batch. There was no choice. You should know entire syllabus, right? 25 questions were there and you have to solve all the questions. You already know you have passed JEE CET exam. I need not tell you. Okay. So now this is how it is drawn from the specification. This is called as passband, right? Now what else is given? H omega, it is less than or equal to 0.2, it is less than or equal to 0.2, this is this range, right? In the range 0.65 to 5. This is in the range 0.65 to 5. So this line, is it okay? I hope you are understanding. This range, this is this range. Is it okay? So this is a AP and this is AS. So now this band is called as pass band. It is the low pass filter because low frequencies from 0 to 0.2 pi are passed, and this is the tolerance which is acceptable. Actually, we should get all the frequencies, gain should be 1, but it can come to 0.8. This is acceptable in case of practical designs, right? So now similarly for AS it should be actually 0 from this place, but it is acceptable to 0.2, so it can be below 0.2 like this. So now this WP is called as, what is it called? Who will tell me? What is this? Yes, nomenclature for WP. MCQ question. What is W key? Yes, tell me what is WP and WS? What is WP and WS? It is not cutoff frequency, Rahul. Yes, passband age frequency. Correct. Passband age frequency, stop band age frequency. What is the definition of cutoff frequency? This is the preparation of MCQ. This is the preparation of MCQ. What is the definition of cutoff frequency? Tell me now. Rahul? How do you define cutoff frequency? You have studied so many filters. This is the last but one question, last but one lecture. Tell me. Unless all the concepts are clear, we will not proceed. Otherwise, you won't be able to solve these MCQs. If descriptive, it is okay. This is Neha, everyone. Yes, WP is passband age frequency. Now my next question to you is, what is the definition of cutoff frequency? Definition I am asking you. WC is okay. You call this as a cutoff frequency. I am asking you definition of cutoff frequency. Now you are studying filters since last, I think so many lectures I have covered, and earlier also you have studied. Let me know. Yes. Okay, you can refer the whatever resources you have. You can refer the book, whatever resources you have, and tell me. All the students must tell what is the definition of cutoff frequency of any filter, digital filter, analog filter. Yes. Write down in the chat box, then we will proceed. You can use the resources which you have. Write down answer. Filter response where a transition band and pass band meet. No. It is See, cutoff frequency will lie between transition band and pass band. Cutoff frequency is the frequency beyond which the filter will not pass the signals. 3 dB, correct. Attenuation is 3 dB. So what is the frequency? Yes, this is also correct. Power is half or 3 dB frequency. So now see here. Now see here. If this H, if it is 1, now suppose cutoff frequency is somewhere here. It will lie between pass band and stop band, right? So what value you can expect? Tell me. Suppose this is the cutoff frequency, right? For example, I am telling you in between point 0.2 pi to WS. This is very sure that it will lie between 0.2 pi to pi. So what if this is 1? What should be this value? Who will tell you? At below 3 dB, it is okay. If it is in dB, it is below 3 dB, but it is not given in dB. It is not given in decibel. It is given 1. So tell me, what should be this value? Now you are close to answer. This 3 dB is okay, Devashri. I am asking you, what is the, if this is cutoff frequency, suppose it is 0.4 pi. For example, let it is be 0.4 pi. At cutoff frequency, what should be my gain? This is 1. At this point, what should I get? The value. Again, MCQ. Multiple choice question. What is the value given to you? The options are, yes, 1 by root 2, 1 by 2, and 0.75. Tell me which option is correct. Which option is correct? Yes. At cutoff, if see, I have given you so many materials, so many slides also. There also you can find out. No, 1 by 2 is power becomes half. Sandhya, 1 by root 2 is correct. Sandhya is correct. Devashri, power becomes half. This is not power. This is gain. One is VO by VN. You have performed so many experiments in the lab. It is VO by VN. 1 by root 2 is correct answer. So at this point, I want 1 by root 2. That is called as cutoff frequency. Rahul Thorat, have you understood? Rahul to answer. Have you understood? Yes. The definition of cutoff frequency. Okay. Other students also must concentrate. You have to solve either theory question paper or MCQ. We don't know what type of pattern will be there. You should be prepared for both, right? And you cannot put anything on option. Now, given specifications are of digital filter, which I have already cleared. That also it took time for you, right? So these are AP is passband attenuation, WP is passband age frequency, AS is stop band attenuation, WS is stop band age frequency. Now, what is the step number 1? What is the step number 1? Yesterday you have written all the 6 steps. Step number 1 is calculate specifications of analog filter, convert digital filter specification to analog filter. Now, why we are using this transformation omega equal to 2 by Ts tan of W by 2? Because we are using bilinear transformation, which is mentioned. Is it okay? Everyone is getting? I hope, right? So now in MCQ, they might give you this frequency and write down omega p by using bilinear transformation. They might give you WP and write down what is omega p in MCQ. So you should understand whenever bilinear transformation is there, omega equal to 2 by Ts tan of Wp divided by 2. Right? So now the first step is converting digital to analog specifications by omega p equal to 2 by Ts Wp by 2. So now Ts is not given. So you can assume this as a 1 second. But you should write there. Now this is how you have got omega p. Next, you determine omega s. Omega s is analog stop band age frequency. It is again by using this formula, right? You have got the value 2.75. So now these are again MCQ questions, right? Now what is the next step? Step number 2. Step number 2, yesterday you have written all the steps. Step number 2 is calculate order of the filter. Sometimes there is a question for 5 marks. You are given the specifications and calculate order of the filter n. So in that case, you should know the formula. So now this formula is used because the gain is given directly. It is not in dB. If it is given in decibel, formula changes. Or you may convert it. You know the conversion, decibel to the normal and normal to decibel, right? So now order of the filter n is equal to half log of 1 by as square minus 1 divided by 1 upon ap square minus 1 divided by log of omega s by omega p. Is it understood? Understood? No, you have to remember this is the formula for order of calculating order of Butterworth filter. I am going into the details of Butterworth filter. Chebyshev filter only formulae will change and you do yourself. Only there is a change in the formulae, that's all. These are two different researchers who developed this design technique, right? So now n equal to half log of AS is given 0.2 stop band, yes, attenuation. So 0.2 square minus 1 divided by AP is given 0.8 square minus 1. And omega S and omega P you have calculated. This is omega S is 2.75 and omega P is 0.65. This is not WP and WS. Keep in mind, this WP and WS is not there. This is omega, capital omega, means analog, right? Now what is the order of the filter? It is 1.3. You should have practice of calculations. Is it okay? You verify your answers by using calculator. Otherwise, you will know the formulae and it will take time to calculate. It should not happen like this. Is it okay? You got are you verifying the answer? Are you verifying the answer? Okay, n equal to 2. Got it? Now, because we have to round it, always filter, even though order of the filter is 1.4, 1.3, 1. You round to next higher value. So it is taken as n equal to 2. It is the order of the filter. What is the next step? Calculate omega C. Now this is the cutoff frequency. Rahul and all other students, this is the cutoff frequency, omega C. WP was not cutoff frequency, omega P is different, omega S is different, omega C is different, right? Now we have the formula to calculate cutoff frequency omega C. How to calculate it? Omega C equal to omega P divided by 1 by AP square minus 1 raised to 1 by 2N. See, step by step, whatever we have calculated, we are using in the next step. The parameters which we are calculating, we will be using in the next step. And the specifications are, you are given specifications of digital filter. So step by step, we are using all the steps, right? If you know the formula, it is very easy. Formula, and of course, you should know the significance, right? Now calculate cutoff frequency omega C with the help of this formula. Omega P is passband edge frequency. AP is, yes, it is attenuation in passband, which is 0.8. So this is 0.65 in radian. 0.8 square minus 1 raised to 1 by 2n. Why it is 1 by 4? Because n is equal to, yes, n equal to 2. So 2 into 2 is 4. That's why it is 1 by 4. I hope everyone is getting. See here, 0.75 is the cutoff frequency. Got it? See, yes, 0.75. Actually, it should lie in between these two. I don't know. This is a practical, theoretical and practical difference. Oh, sorry. Yes, this is omega C. And whatever is given, you are given, yes, you are given, what is given? This diagram is for digital filter and we have calculated for analog filter, right? So this is for analog filter, capital omega C. So you cannot draw there, right? So it is 0.75. And the cutoff frequency definition is your gain falls. If the gain is 1, it will be 1 by root 2. If it is given in dB, it is minus 3 dB. Right? So now that's why it is called as 3 dB frequency. And power becomes half. Now this is the cutoff frequency which is different from omega P and omega S. Is this okay? Now, what next? Calculate poles of the filter H of S. Because if you know H of S, you can find out H of Z. Now, how to compute H of S? Again, for calculation of poles of the filter, you must know this formula. Right? So, this is the formula which you should know. What is that? Pk equal to plus minus omega C is used here, which is cutoff frequency, e to the power j capital N plus 2k plus 1 into pi. Or you can write down k e to the power j pi in bracket n plus 2k plus 1 divided by twice n. This again you should know how to calculate what is the formula for calculating poles. Sometimes they may give you H of S. See, sometimes they may give you omega C and order of the filter. Calculate poles or determine H of S for 5 marks. For that, you must know this formula and concept should be clear. And K should vary from 0 to n minus 1. What is n? Capital N is order of the filter and it is equal to 2. Means number of poles are 2. Right? So 2 minus 1 is 1. So 0 and 1. Only P0 and P1 you have to calculate. So how to calculate P0? See, now proceed. Put omega c equal to 0.75. This is 0.75. Then n is equal to 2. 2k plus 1 pi divided by again 2 into n, that is 2 into 2 is 4. Is it okay? Same thing is simplified here. 2 plus 1, 3, like that. So this is pk. Now put k equal to 0 to get p0. Right? K equal to 0. So it is e to the power j 3 pi by 4, which is cos 3 pi by 4 plus j sin 3 pi by 4. Right? And you can compute this like this. So this is the value. So for P0 you are getting plus minus, yes, 0.35 plus j 0.53 and 0.53 minus j times 0.53. P0 plus minus, right? Are you getting? Shall I go ahead? If you have any doubt, you can unmute and you can ask me. All the students, if you are having any doubts, you can unmute and you can ask me. Is it okay? Are you okay? Yes? I need to wait for the response. Okay. Only 2-3 students are attentive, it seems. Let it be. It is up to you. I told you, it is your responsibility to learn. Everyone should know this, right? Okay. So now we have computed P0. Next we have to compute P1. Same way, put k equal to 1. K equal to 1 here. So you are getting like this. Now I have explained for this. I say similarly you can follow this. So you have got P1 equal to this. Right? Now you got P0, you got P1 and plus minus. So total, even though we have computed for 2 poles, you have got 4 poles. Right? Now you can plot it. The next step is you can plot it. This is sigma j omega. Why we have taken sigma j omega? Because we are still in S domain. We are in analog filters. We are computing h of s. That's why it is sigma and j omega. This is not z plane because we are still in the designing of analog filter. First we will determine h of s. Then we will convert this h of s to h of z. This is capital H, right? That's why this is P1, P0, P0, P1, P2, P1. So see here, this is antisymmetric poles, complex conjugate poles, plus J, this is minus J, plus J, minus J, like this. Complex conjugate poles you will find in case of Butterworth filter, right? So now, see, if I want, and we will always need a practical filter should be a stable filter. So who will tell me what is the condition for the analog filter to be a stable filter? Poles should lie. Where should be the poles? Yes, write down. Where should be the poles? Devashri. Because we need always, yes, Rahul. It should be left half of S plane. Right? Here it is already given. If you read that, then also you will get. So now on the left hand side of S plane, these two poles are lying. And I will not consider these two poles because filter will become unstable. That's why we are taking only these poles, So consider these two poles, P0 and P1. Don't consider these poles, right? So now you will get like this, both on this side, right? So take this omega c, then write down h of s, omega c raised to n. This is also formula. Last time I have given you all the formulae, and now we are using omega c raised to n. Omega c is cutoff frequency of analog filter. N is 2, order of the filter, divided by s minus s1. These are the two poles, right? S minus S1, S minus S1 star, or you may write down S1 0, S0 and S1. Nothing will happen because you have got these two poles which are on the left side. To have filter, stable filter, right? So these two, now you can simplify this, right? You will get this answer. This is H of S. Now last step is remaining. Have you understood this? All the students? Rahul, is it clear? Yes, Rahul. Okay. So now, okay. So you know H of S. What is the last step? What is the last step? I have got H of S. Is the filter designing over? Is the filter designing over? Yes. Devashri, you are correct. You have to convert it digital to digital domain. So you have to map from H of S to, you have to determine H of Z, because this is the, we are studying digital signal processing and we are studying digital filter design. So you need to determine H of Z. Our aim is to determine H of Z and not to determine H of S only. Why we are determining H of S? Because unless we determine H of S in case of IIR filter, you cannot find out H of Z. It was possible in FIR filter designing, but it is not possible here. That's why next step, last step is obtain the transfer function for digital filter. This is the last step. Now I will leave this to you. You solve and write down in the chat box how you are going to do using bilinear transformation method. Yes. How you are going to do? Tell me. All the students should answer for giving attendance to. How to convert HS to H of Z? This is the last step. If you are asked to take bilinear transformation method. All the students should write in the chat box, and of course final answer. Yes, Devashri, you are correct. You have to, yes, you have to replace S by 2 by T, Z minus 1 divided by Z plus 1. It is okay. So replace S by 2 by TS, Z minus 1 divided by Z plus 1. And TS is 1 considered. Now it is your work to do. Okay. Neha, correct. So now capital T is 1 second. and Z should be a small letter. Keep in mind, Neha, S is a small letter, Z is a small letter. Don't write capital letters here. Right? Now, okay. Now you do determine H of Z. This is your job. Determine H of Z and write down in the chat box. If simplification is possible, well and good. Otherwise, determine H of Z. Okay, Sandhya, procedure is okay. Now you determine H of Z. Not only by giving the, you substitute S equal to 2 by T. Haan. Substitute S is equal to 2 by T, Z minus 1 divided by Z plus 1 and determine H of Z.